Welcome to Easy Maths. In this video, we're going to be looking at geometric series, or if you like, geometric progression, which is normally called GP also. This series is obtained by the addition of numbers or terms in the geometric sequence. Normally, it's represented by Sn, which is the sum of the first n terms of that particular sequence. Now, therefore, for GP series, this Sn will be simply this kind of a thing because we're adding the terms that there are in that particular sequence. This is the first term, second, third, fourth, all the way up to the last term. However, we need to form a formula which is useful in attempting to do the sum of terms for any GP series, because in this case, it's too general. We don't know the number of terms, and also we don't know how many terms there are between these ones here. Anyway, this formula is simply not good. We need to come up with a better one. So to begin with, you're going to set this formula to be 1, or Roman 1, and we're going to come up with another formula, which is Roman 2. First of all, by multiplying both sides by r, so that we have Sn times r becomes Rsn. All of these other terms will become as it's written here. For a, it will become ar will become ar squared will become ar cubed will get ar raised to 4 here. For ar raised to n minus 2 will become ar raised to n minus 1, and ar raised to n minus 1 will become ar raised to n, and that will become Roman 2. This is Roman 2, the other one there is Roman 1. For the operation of ar raised to n minus 2 and ar raised to n minus 1 multiplied by r to get this 2 here, we are using the concepts that are available in indices, and so you can check them out and verify. Having obtained that, we're going to subtract equation 2 from equation 1 in this particular way so that we obtain what we have there. Now, before the equal sign, we're going to simply have Sn minus Rsn. However, after the equal sign, we only have 2 terms that are remaining. Every other one will be eliminated. The ar will be eliminated by this other one here. Ar squared will be eliminated by this other one here. Ar cubed, this one here, up to the last term here will be eliminated by the second last for the Rsn. And therefore, only the first one for Sn and the last one for Rsn will remain. And these are the ones here. At this stage, we're going to factorize both sides. Here, the common factor is Sn. After the equal sign, the common factor is a, and so factorizing that out to get this one here, and divide both sides by 1 minus r, which will give us this particular formula. Now, this formula here is the formula for sum of terms for a GP series when the value of r is less than 1. There is its alternative that is used when the value of r is greater than 1, and that's generated as follows. Instead of subtracting equation 2 from equation 1, we're going to subtract equation 1 from equation 2 in these 2 equations here. And so you're going to have this, them written this particular way so that when you subtract, you get Rsn minus Sn before the equal sign, and after the equal sign, all terms will go away except the last one for Rsn and the first one for Sn, as we did in the previous case, only that this time around they're going to be reversed. And so having them like this, we're going to factorize whatever that is possible after and before the equal sign. So before the equal sign, the common thing is Sn. We factorize it out as it is seen here, and after the equal sign, we're going to factorize out a, which is appearing like this. Now, dividing both sides by r minus 1, we're going to get this formula, which is used whenever the value of r is greater than 1. And so for the sake of our emphasis, please notice that this formula here, the first one, is used whenever the value of r is greater than 1, less than 1, and the second one here is used when the value of r is greater than 1. So take care of that, even as you operate questions. Look out for the value of r. And the reason is normally because denominator can make the answer to be negative when it's actually not supposed to be negative. So to avoid that, we use the appropriate formula. When the value of r is less than 1, use this one here. And when the r is greater than 1, you use the second formula there. We're not able to do examples or try out an exercise in this particular lesson, so we'll do it in the next lesson. And so check out for that. I have 2 videos that will be dedicated specifically to that, even as we continue in our series of lessons on the topic of sequences and series. Please, as always, like, share, and subscribe. I'll appreciate. Thank you.